There are no simple formulas for Bell numbers, so the equation that we use to calculate them is actually a recurrence relation. How do we prove this recurrence relation? Well, we start by considering a partition of a set of numbers from 1 to n plus 1. And suppose that n plus 1 is in A1 and that the size of A1 is k plus 1 for some k in between 0 and n. Then the rest of the elements form a partition of the remaining n minus k elements of the set. The numbers of partitions of the set is the n minus kth Bell number. There are n choose k sets of size k plus 1 containing n plus 1, so the total number of partitions in the set in which n plus 1 is in a set of size k plus 1 is n choose k times n minus the kth Bell number. After a little rewriting, we get the expression at the bottom. You may have noticed that the Bell triangle looks similar to something else that we have learned about, Pascal's triangle. We know that Pascal's triangle is made up of binomial coefficients, and each number can be determined by the binomial coefficients in the previous row. If we look at the formulas and triangles for each, we can see similarities. Both the Bell numbers and Pascal's triangle involve binomial coefficients, and the construction of both triangles involve using the sum of two values in the previous row. One of the interesting applications of Bell numbers is that they can be used to count the number of possible rhyme schemes of a poem. If we take a look at this wonderful limerick about discrete math, the first two lines and the last line rhyme with each other, and the remaining lines rhyme with each other, so we can associate the same letter to the lines that rhyme with each other to get a rhyme scheme of AABBA. But how many of these rhyme schemes can we make when given an n-line poem? The possibilities of distinct rhyme schemes for n equals 1 through n equals 4 are listed here. In a one-line poem, there's only one possible rhyme scheme, and in a two-line poem, there are two possible rhyme schemes. In a three-line poem, there are 5 possible rhyme schemes, and in a four-line poem, there are 15 possible rhyme schemes. We can see that the sequence resembles some of the Bell numbers. When we take into account that there's only one set of rhyme sequences for an empty poem, we see that the numbers correspond to the first 5 Bell numbers, 1, 1, 2, 5, and 15. This is the case for any n-line non-empty poem. The number of possible rhyme schemes will correspond to the n plus 1 Bell number, and of course,